All right, so the last one of these Riemann sums we have is called trapezoidal rule. And it's actually not quite a Riemann sum, but it's a more accurate way to approximate a curve. So far with like the left rule and the right rule and the midpoint rule, there was a lot of wasted space. Like when we did the left rule, this would be the area we get, but you're wasting all of this extra space up here. And then with the right rule, the right hand rule, it's the opposite. You're wasting extra space above the curve. And the midpoint did a better job, but the trapezoidal rule is like kind of the most accurate way we have. And so what the trapezoidal rule does is instead of using rectangles to approximate the area, they use trapezoids. So, we would take this point, if we're going from A to say B over here, we would take A, and then whatever our intervals, like if we're breaking it up into so many intervals, say these are all the intervals we made, you just take both of these and you make a straight line, and that's a trapezoid right there. And then again, you go over to B, you make a straight line, and there's another trapezoid, and you just keep going until you have a bunch of trapezoids. And so sometimes with this, you'll waste more space than other times, but it's a lot less wasted space than when we did the rectangles. And so if you guys remember from geometry, the area of a trapezoid is base 1 plus base 2 times the height divided by 2. And in this case, if you guys notice, the height for this is actually going to be like what we had been calling the width. So like this would be base 1, this would be base 2, and then down here that would be the height. So what we've been calling in our class, what we've been calling like that width, which was the b minus a over n, that's the height in that formula. We'll keep calling it the width, but that's the height. And then this base 1 and base 2, those are just our f of x's. So base 1 would be like f of x, and then base 2 would be like f of x plus, one subinterval, so whatever n is. So whatever we're counting by. So in this case, sorry, it would be plus w, whatever we're counting by. We count by the w. So in this case, though, if you notice, we have all of these trapezoids, and in this first one, the left side will be B1, the right side will be B2. But then in the next trapezoid, what happens, let me get another color. What happens is that this side right here gets repeated as B1 and B2. And if you guys see all of these heights right here, all of these middle heights that I'm coloring in orange are going to be part of two different trapezoids. So they're all going to be used twice. But then the end heights are only ever going to get used once because they're only part of one trapezoid. So when we get to our formula, what happens is we're going to use all of those f of x's twice in the middle and the outside ones once. So our formula, we take b minus a divided by n, and then we multiply just 1 for the first one, like this would be f of x, plus, right, and we'll call that like f 0 of x, or like y0, right, plus now it's our first x, which would be this first point here, but we do that twice, so I'm going to say plus 2 f1 of x, plus 2 f2 of x, and we keep going, so I'm just going to say plus dot 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 until the very last point, that fb of x, that only happens once. Alright, so all of these middle points happen twice, the outside ones happen once. And then what we also have to do is we have to divide everything for this area formula. We divide everything by 2. So we divide it all by 2. And what I like to do is instead of dividing everything by 2, we already have a fraction. So I put the 2 in there with that b minus a over 2n. Okay. So, or what you can do is you could do like b minus a over n divided by 2 everything. But that's just a little bit weirder. So using y's like we were doing before, the trapezoid rule formula will be b minus a over 2n times y0 plus 2y1 plus 2y2 plus dot dot dot. I'm going to just put 2 yn minus 1. That's like the point before the last one. So we know everything's being multiplied by 2 except for the first y and the very last y. So that's our trapezoid formula. Now the one thing to be careful about is that this b minus a over 2n right there, that's not going to be your width. That's not what you're changing by because of the 2. You're still only changing each time. Like that width that we're changing by each time is still just b minus a over n. So sometimes people like to write this as like, that w over n there. And then you just plug in b minus a over n because you know that each point is changing by w. So hopefully this will make a little bit more sense once we do our example. So the example that I have is a little bit of like a harder one because we're going to use e to the x. And again, this symbol right here, that squiggly, that's going to be an integral. So what this means, that means that integral means area under the curve. And we're going from 0 to 2. And don't worry about the dx for right now. We're just going to kind of pretend it's not there. So we're going to approximate this integral with 4 subintervals. So that means my n is going to equal 4. And then a, my starting point is 0. And my ending point b is going to equal 2. So using the trapezoid rule, right, we know that w, that width, is equal to 2 minus 0 over 4, which is going to be a half or 0.5. And then my trapezoid rule, remember, is w over 2 times y0 plus 2y1 plus all of those guys until we get to the endpoint. So we know that we're counting by 0.5, so we're going to do like f of 0, f of 0.5. So I'm going to make this 1/2 over 2 times f of 0 plus f of 1/2. Sorry, 2 times f of 1/2 plus 2 times f of 1 plus 2 times f of 1.5 plus, and then just 1 f of 2 because that's the end. All right, so these outer endpoints only get 1 and everything else gets multiplied by 2. That's the weird thing about trapezoid rule. So 1/2 over 1/2 is 1/4 times, then we're going to plug these all in. So that's like e to the, it was e to the 2, or sorry, x squared. So that's like e to the 0 squared, 2e to the 1/2 squared, 2e to the 1 squared, 2e to the 1.5 squared, 2e to the 2 squared. And once you plug that all into your calculator, all right, you're going to get 1/4 times some number on your calculator. And sorry, when I did this, I forgot to figure out what that number was. But my final answer that I got, and you guys can check this on your calculators. The final answer that I got was 20.644. All right, and then we're gonna have one more video. It's gonna be quick, and it's just gonna be talking about which one of these are the most accurate and which ones are the least accurate. So since we're live streaming this, we had a really good question, and it was, we don't do the left and the right here. Like you don't only do the left, or you don't only do the right. On this, you do every single f of x. So you do the left one, and you do all of them, all the way until the right side. So you do get to every single f of x, but just these n2 points don't get multiplied by 2, and everything else does. All right, so Victor failed to mention this, but one more really good question is, even though it says n equals 4, so even though it says we have 4 intervals, on the trapezoid rule, you get 1 extra, f of x. So we have 1, 2, 3, 4, 5 points that we're using, even though it's only 4 intervals. So whatever n is, you're gonna have 1 extra, because you have the left endpoint and the right point and all of your middle ones.